Chapter 1, Lesson 2, the Geographer's Tools. Lesson 2 can be found on page 26 in your textbook. Mr. Shane's going to read as you can follow along through the reading, and also make sure that you have your notes handy ready to go to complete as we go through each of the 3 sections in each of the paragraphs. Our essential question for this lesson and many lessons in geography is, how does geography influence the way people live? As we're learning more about the world, we want to understand how it influences the people in the places in the world. Using globes and maps. Our guiding question: what is the difference between globes and maps? If you close your eyes, you can probably see your neighborhood in your mind. When you do, you're using a mental map. You're forming a picture of the buildings and other places and where each is located in relation to the others. Making and using maps is a big part of geography. Of course, geographers make maps that have many parts. Their maps are more detailed than your mental map. Still, paper maps are essentially the same as your mental map. Both are a way to picture the world and show where things are located. Now, as we study globes and maps, I want to get you into a good mood here. So I got a couple jokes for you to get you ready for what it is that you're about to learn. These tools that we're going to use as geographers. Pirates, a lot of times when they were sailing the sea, didn't have globes or maps, so they were kind of going on their own. What's a pirate's favorite country? Argentina. Get it? What always sits in the corner but can move all around the world? This is called an oxymoron. It can do one thing and the other. Shouldn't be able to do both at the same time. Sits in the corner but moves all around the world? Of course, that's a stamp. Now let's read about globes and maps. The most accurate way to show places on Earth is with a globe. Globes are the most accurate because globes, like Earth, are spheres. That is, they are shaped like a ball. As a result, globes represent the correct shape of land and bodies of water. They show distances and directions between places more correctly than flat images of Earth. The equator and the prime meridian each divides Earth in half. Each half of Earth is called a hemisphere. The equator divides Earth into sections called the northern and southern hemispheres. The prime meridian, together with the international dateline, splits Earth into eastern and western hemispheres. If you look at the bottom of page 27, you can see how those separate lines separate the world into said hemispheres. Northern hemisphere and southern hemisphere, again divided by the equator. The western hemisphere and eastern hemisphere divided by that prime meridian and international dateline. 8th grade, let's actually look at the parts of the globe to better understand what all these different lines and pieces of information might tell us about the world that we're studying. You see these tiny, tiny little lines on here. Look really closely. These are latitude and longitude lines. Now we know that if they're horizontal like this, that's latitude, because latitude is flatitude. That's how you're going to tell those differences. The main latitude line is right here going across the middle. That's our equator. It cuts the Earth into the 2 hemispheres, the northern hemisphere and the southern hemisphere. From that latitude line, there are individual lines that increase in their value as they go from 0. So 0, it increases as it goes away from 0. 0 increases as it goes away from 0. These would be our degrees north, and these would be our degrees south. Now if you look here in what is England, there's a famous city called Greenwich, England, in which the line that cuts right through this and then comes down here through this northern portion of Africa into the Atlantic Ocean, that is the prime meridian. The prime meridian, and on the other side of the Earth it's called the international dateline, actually create what is the longitudinal way in which the Earth is divided into these north and south sections. Now, that splits the Earth into an eastern and western half, even though those lines are running north and south. It's really cool, and what maybe you didn't know is the reason why the prime meridian has a different name on the other side of the world is because this is where it's called the international dateline. As in, when the world is spinning and it gets to the point where the next day is going to be starting a specific time, that line is what marks what one part of the world is in the next day and the other part of the world is in the previous day, as in the hour of each part of the day. So this line even says right here that this part of the world would then be in Monday while the rest is in Sunday, and then as these people are moving past that midnight portion on Sunday night and into Monday morning, that's where that begins at that point on the opposite side of the prime meridian. Again, we've got northern hemisphere, southern hemisphere, we've got the western hemisphere and eastern hemisphere, and the lines that divide those different pieces of the earth. Maps. Maps are not round like globes. Instead, maps are flat representations of the round earth. They might be sketched on a piece of paper, printed in a book, or displayed on a computer screen. Wherever they appear, maps are always flat. Maps convert or change a round space into a flat space. As a result, maps distort physical reality or show it incorrectly. This is why maps are not as accurate as globes are, especially maps that show large areas of the whole world. If you want to try to see if this is actually true, next time that you're peeling an orange, I want you to try and peel the peel off of the fruit on the inside of it by making it as one piece as possible. You can do this by rolling the orange on the table and loosening the rind, the peel on the outside from the fruit on the inside, and then try and peel that apart in one piece. If you can, that's great, and then try and lay that piece flat, or if you can't, and all the pieces that you take off of that, try and lay it flat to make a round shape, a spherical shape, into what would be the rectangle. You'll notice that there's a bunch of pieces missing. When those pieces are missing, map makers, cartographers, actually have to stretch different pieces of the actual map to fill in those gaps. Therefore, the distances and the shapes of those things can somewhat be distorted on a map. Despite this distortion, maps have several advantages over globes. Globes have to show the whole planet. Maps, though, can only show part of it, such as one country, one city, or one mountain range. As a result, they can provide more detail than globes can. Think about how large a globe is and how large it would have to be to show the streets of a city. You could certainly never carry such a globe around with you. Maps make more sense if you want to study a small area. They can focus on just that area, and they are easy to store and to carry. Maps tend to show more kinds of information than globes. Globes generally show major physical and political features such as land masses, bodies of water, and countries of the world, and the largest cities. They cannot show much else without being too difficult to read or too large. However, some maps show these same features, but maps can also be specialized. One map might illustrate a large mountain range, another might display the results of an election, yet another could show the locations of all the schools in a city. Now, why are globes the most accurate way to show places on Earth? Because they're not distorted. They actually show the real shape. What's a disadvantage of using a map? Well, maps can be distorted, therefore not giving you accurate information in terms of the actual distance or the shape of certain things. However, maps have a huge advantage in terms of being able to be very much so specialized or focus in on a smaller area with specific information. Let's learn a little bit more about maps. All about maps on page 28. Guiding question says, how do maps work? Let's figure it out. Got a couple more jokes for you. Why do paper maps never win poker tournaments? If you know anything about poker, you've got your hand of cards. If you don't have a good hand, you're actually going to fold. Paper maps always fold. Question number 2, joke number 2. Hope you're laughing. What do maps and fish have in common? Well, maps have scales, and fish have scales. We'll learn about how we use those scales to measure distance as we continue reading. You will find maps in many different places. You can see them in a subway station. Subway maps indicate the routes each train takes. In a textbook, a map might show you blah, 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 blah. Don't like that, don't like that, don't like that, don't like that, don't like that. All about maps on page 28. Our guiding question, how do maps work? Before we jump into our reading, I want you to tell another couple jokes. Why do paper maps never win poker tournaments? If you know anything about poker, when you are caught with a bad hand, you're most likely going to fold. I mean, throw your cards in because you don't want to be a part of the bet anymore. Well, paper maps, they fold up too, and get it? What do maps and fish have in common? Well, let me tell you, we're going to learn about these features in a map. A map has a scale to tell us distance. Fish also have scales. Get it? Get it? Let's get started. You will find maps in many different places. You can see them in a subway station. In a subway map, indicate the routes that each train takes. In a textbook, a map might show new areas that were added to the United States at different times. At a company's website, a map can locate all its stores in a city. The map of a state park would tell visitors what activities they can enjoy in each part of the park. Each of these maps is different from the others, but they have some traits in common. Parts of a map. Maps have several important elements or features. These features are the tools that convey information. The map title tells what area the map will cover. It also identifies what kind of information the map presents about that area. The key unlocks the meaning of the map by explaining the symbols, colors, and lines. The scale bar is an important part of the map. It tells how a measured space on the map corresponds to actual distances on Earth. Here's an example of a scale bar. You see the measurement in kilometers. You would take some type of reference point of a distance and then show that on the map. That distance on the map is going to represent that many kilometers or that many miles. For example, by using the scale bar, you can determine how many miles in the real world each inch on the map represents. The compass rose shows direction. This map feature points out north, south, east, and west. I always remember it by saying never eat soggy waffles. Some maps include insets that show more detail for smaller areas such as cities on a state map. Many maps show latitude and longitude lines to help you locate places. Map projections. To convert the round Earth to a flat map, geographers use map projections. A map projection distorts some aspects of Earth in order to represent other aspects as accurately as possible on a flat map. Some projections show the correct size of areas in relation to one another. Other map projections emphasize making the shapes of areas as accurate as possible. Some projections break apart the world's oceans. By doing so, these maps show land areas more accurately. They clearly do not show the oceans accurately, though. Map makers, known as cartographers, choose which projection to use based on the purpose of the map. Each projection distorts some parts of the globe more or less than other parts. Finally, map makers think about what part of Earth they are drawing and how large an area they want to cover. A couple examples of those map projections. The one on the left is called the Mercator projection, which tries to take what would be a spherical shape and put it onto a flat piece of paper. Obviously, to do that, there's going to be some distortions. The efforts to create the most accurate type of map, even though that's going to be one of its pitfalls, is to a lot of times just use the ocean as the filler space. Another example of that map projection is to do a somewhat rounded shape because the Earth is round, so they create a rounded projection with these rounded edges and try and keep, again, the shape of the actual continents or the land masses as accurate as possible. This is called a Robinson projection. Next, we have map scale. Scale is another important feature of maps. As you learn, the scale bar relates distance on the map to actual distance on Earth. The scale bar is based on the scale at which the map is drawn. Scale is the relationship between distances on the map and on Earth. Maps are either large scale or small scale. A large scale map focuses on a small area. An inch on the map might correspond to 10 miles on the ground. A small scale map shows relatively a large area. An inch on a small scale map might be the same as 1,000 miles. Each type of scale has different benefits and drawbacks. Which scale to use depends on the map's purpose. Do you want your map of your school and the streets and buildings near it? Then you need a large scale map to show this small area in great detail. Do you want to show the entire United States? In that case, you need a small scale map that shows the large area but with less detail. Notice how those two things are opposite of each other. If it's a large scale map, it actually shows a small area because it's zoomed in. If it's a small scale map, it shows a large area because it's zoomed out to include all of that area with less detail. Here's an example of a zoomed in map on the city of Milwaukee. Now, Mr. Shane, since he's lived here, has come to get to know the areas of Milwaukee quite well and how to actually navigate in Milwaukee really easily. If you see this view from what would be a top-down view, you see that all the streets actually run in this grid-like system. So we've got streets that are running north and south, and we've got streets that are running east and west. And the city planners actually tried to do this on purpose, and the names of those streets that are in our city have that code in them. Basically, if you're driving on a street that has a name to it, like Capitol Drive, Mr. Shane drives to school and on Capitol, then he's going to be going east and west. Now, if I'm on a numbered street, all of the numbered streets in the city of Milwaukee actually run north and south. Now, there's a couple different distinctions between, say, a Teutonia or a National Avenue. Some of those have the sideways or this angle going from an inner part of the city to an outer part of the city and vice versa. They're going to be a little bit different, but for the most part, those streets run north and south. And this large-scale map of the section of Milwaukee is going to show that detail. Types of maps. The two types of maps are general purpose and thematic. The type depends on what kind of information is drawn on the map. General purpose maps show a wide range of information about an area. They generally show either the human-made features of an area or its natural features, but not both. Political maps are one common type of general purpose map that show human-made features. They show the boundaries of countries or the divisions within them, like the United States of America. They also show the locations and the names of cities. Here's an example of a political map of the continent of Africa. Now, if you looked at Google Earth or a view from space of what Africa looks like, it's not these different colors. It doesn't have the names painted right on them, and you can't actually tell where the borders are between those different countries. This political map shows where those human-made borders are to allow each country to have its own territory or its own property. A physical map looks a little bit different. Physical maps display natural features such as the mountains, valleys, rivers, and lakes. They picture the location, size, and shape of these features. Many physical maps show elevation or how much above or below sea level a feature is. The map often uses colors to represent this information. A key in the map explains what height above or below sea level is, or what color each color represents. Now here's a picture of a part of Europe. This is actually France, and you have right down here what would be the Swiss Alps and the Andes Mountains, and they show this darker color, meaning that those are significant mountain ranges. As the colors get a little bit lighter, these orange are still going to be hilly type terrains, and yellow, a lowering in elevation. Where you get to green, it's a lowland or plains type area. You see that that lowland area is always going to be commonly associated with where actually the coast is, because then you're closer to what would actually be sea level. Here's a relief map that shows that same type of physical feature, those same mountain ranges that are sticking out without actually having the color. So here it's actually popping out of the page to demonstrate that elevation. Otherwise, a flat map has to use that color distortion to show you that difference. Physical maps usually show relief, or the difference between the elevation of one feature and the elevation of another feature near it. Elevation is an absolute number, but relief is relative. It depends on other landforms that are nearby. The width of the colors on a physical map usually show the relief. Colors that are narrow show steep places, and the colors that are wide show gently sloping lands. A thematic map shows more specialized information. A thematic map might indicate the kinds of plants that grow in different areas. The kind of map is a vegetation map. Another could show whether farming or ranching or mining takes place. That kind of map is called a land use map. Road maps show people how to travel from one place to another by car. Just about any physical or human feature can be displayed on a thematic map. Here's an example of a map conveying some different information. This would be the map of the constellations. Or, if you're in search of buried treasure, in Argentina, you might use a treasure map and find where that X is on the spot. Our reading progress check asks us, how do two main types of maps differ? If you go back on page 29, the two main types are general purpose and thematic. General purpose have more of a broad scale showing either political or physical features, one or the other, whereas a thematic map is going to show something very, very specific. Geospatial technologies on page 30. Guiding question, how do geographers use geospatial technologies? You ever seen maps on cell phones or GPS devices in cars? These electronic maps are an example of geospatial technologies. Technology is any way that scientific discoveries are applied to practical use. Geospatial technologies can help us think spatially. They provide practical information about the locations of physical and human features. GPS, or Global Positioning System. GPS device works with a network called the Global Positioning System. This network was built by the U.S. government. Parts of it can be used only by the U.S. Armed Forces. Parts of it, though, can be used by ordinary people all over the world. The GPS has three elements. The first element of this network is a set of more than 30 satellites that orbit Earth constantly. The U.S. government launched the satellites into space and maintains them. The satellites send out radio signals. Almost any spot on Earth can be reached by signal from at least 4 satellites at all times. Second part of the network is the control system. Workers around the world track the satellites to make sure they are working properly and are on course. The workers reset the clocks on the satellites when needed. The third part of the GPS system consists of GPS devices on Earth. These devices receive the signals sent by the satellites. By combining the signals from different satellites, a device calculates its location on Earth in terms of latitude and longitude. The more satellite signals the device receives at any time, the more accurate it can determine its location. Because satellites have accurate clocks, the GPS device also displays the correct time. GPS is used in many ways. It is used to track the exact location and course of airplanes. That information helps ensure the safety of flights. Farmers use it for help when they are working their fields. Businesses use it to guide in truck deliveries. Cell phone companies use GPS to provide services, and of course GPS in cars helps guide us to our destinations. A little bit different, a geographic information system. Another important geospatial technology is known as the GIS, or Geographic Information System. These systems consist of computer hardware and software that gather, store, and analyze geographic information. The information is shown on a computer screen. Sometimes it is displayed as a map. Sometimes the information is shown in other ways. Companies and governments around the world use this new tool. A GIS is a powerful tool because it links data about all kinds of physical and human features with the locations of those features. Because computers can store and process so much data, the GIS can be accurate and detailed. People select what features they want to study using the GIS. Then they can combine different features on the same map and analyze patterns. For instance, a farmer might want to compare the amount of moisture in the soil to the health of plants. At the same time, he or she could add soil types around the farm to the comparison. The farmer could then use the results of the analysis to answer all kinds of questions. What plants should I plant in different locations? How much irrigation water should I use? How can I drive the tractor most efficiently? Mr. Shane uses a GIS system when he's using Google Earth to find what a location looks like. He also uses it when he's trying to find a new place to hunt, because he'll be scouting out what would be a certain property or landmass, maybe it's public land or private land, and a Geographic Information System has taken pictures of the Earth, and you can access that information and then see where different locations are or where different features are on those maps. This all comes together because of the way in which satellites are working in our orbit. Since the 1970s, satellites have gathered data from about Earth's surface. They do so using remote sensing. Remote sensing simply means getting information from far away. Most early satellite sensors were used to gather information about the weather. Weather satellites have helped save lives during disasters by providing warnings about the approaching storms. Before satellites, tropical storms were often missed because they could not be tracked over open water. Satellites gather information in different ways. They may use powerful cameras to take pictures of the land. They can also pick up other kinds of information, such as the amount of moisture in the soil, the amount of heat the soil holds, or the types of vegetation that are present. In the early 2000s, scientists used satellites and GIS technology to help conserve the plants and animals that lived in the Amazon rainforest. Using the technology, scientists can compare data gathered from the ground to data taken from the satellite pictures. Land use planners use the information to help local people make good decisions about how to use the land. These activities help prevent the rainforest from becoming destroyed. Some satellites gather information regularly on every spot in the world. That way, scientists can compare the information from one year to another. They look for changes in the shape of the land or its makeup, spot problems, and take steps to fix them. However, there are some limits to geospatial technologies. Geospatial technologies allow access to a wealth of information about the features and objects in the world and where those features and objects are located. This information can be helpful for identifying and navigating. By itself, however, the information does not answer questions about why features are located where they are. These questions lie at the heart of the understanding of our world. The answers are crucial for making decisions about this world in which we live. It's important to go beyond the information provided by geospatial technologies. We must build understanding of peoples, places, and environments and the connections among them.